So now we're going to go ahead and start topic 2, lesson 3, which is rocks, and it can be found on pages 70 through 77 in your textbooks. All right, so describing rocks. We're going to look at page 71, figure 1, or the picture at the bottom of the screen. And we're going to go ahead and describe the rocks in the landscape. So some things that we could say: it has a reddish tint, it is eroded, it has some weathering that's happened, it looks like it used to be a bigger form. So how does this place change over time? So as weathering and erosion continue, the formation will eventually become smaller and smaller as pieces of rock are removed from it. Kind of similar to how a lot of you did your rock comics, and the rock comic example about the rock changing and weather and everything happening to it, which ultimately just makes it smaller and smaller and smaller. So our connected asks us to draw an outline of what the weathered rock may have looked like 2,000 years ago. So we could say that it probably looked something like that, maybe. You could draw something more like a mountain, whatever you think. But that's pretty much what it's going to look like. And of course, the answer of how do you think the rock formation will continue to change over time was answered earlier. So describing rocks. So the picture that we looked at on the last slide used to be a mountain range that has now withered away. Weathering, erosion, transportation, and deposition or depositation have worked to tear this down. When geologists describe rocks, they use the rock's mineral composition, color, and texture. For example, for figure 1, Towers of Rocks, the label reads, "The striking red color of Monument Valley is the result of iron oxide minerals exposed within the rock." So they definitely used the color, they used the mineral composition, and they didn't quite explain the texture there, but they kind of got into it. Mineral composition and color. Some rocks contain only a single mineral. About 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals, and the different colors in granite shows the different elements that went into making that rock. Texture. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. Geologists use terms based on the size, shape, and pattern of the grains. Coarse-grained rocks are easy to see the difference. Fine-grained rocks can only be seen with a microscope. So, diorite here is coarse-grained, intrusive rock that contains hornblende, feldspar, and occasionally quartz. Granite is light-colored, coarse-grained, intrusive rock which contains mostly quartz and feldspar minerals. Basalt is fine-grained, extrusive rock, dark-colored, contains mostly plagioclase and pyroxene. And obsidian is dark-colored volcanic glass which forms from the cooling of molten rock. It's an extrusive rock and has no crystals. Before moving on to the next page, we're going to go ahead and do the figure 2 claim, evidence, and reasoning. So we're going to circle the best word to complete each sentence. Granite is generally dark or light in color. The granite on this page is light, so we're going to circle that. Granite has a high or low silica content. And we are going to circle high. Then the grains in granite are fine or coarse. And we're going to go ahead and circle coarse for that. So our evidence. What evidence did you use to make your claim? So we used the image as well as the text. And explain how your evidence supported your claim. The image of granite looks light. The text indicated that granite is high in silica, and we can see the large coarse grains in the image. Now we're going to go ahead and do the reading check. So igneous means fire in Latin. What is fiery about igneous rocks? Igneous rocks form from red hot or fiery melted material, like the lava and magma. How rocks form, and then igneous rocks. Igneous rocks are rocks that form from cooled magma or lava. Igneous rocks can look very different depending on the temperature and where the rock was formed. Igneous rocks that form below Earth's surface will look like what? And igneous rocks that form above Earth's surface will look like what? So we're going to look at figure 3 to kind of answer this. So B is going to be what's below Earth's surface, right? And that would be diorite, which is a very coarse-grained, intrusive igneous rock, compared to the rhyolite, which is a fine-grained, extrusive igneous rock with a composition that is similar to granite. So the differences are the grain. One's coarse, one's fine, one's intrusive, meaning that it is in the land, and one's extrusive, meaning that it is out or above the surface. Sedimentary rock forms when small particles of rocks or the remains of plants and animals are pressed and cemented together. Sediment is the small solid pieces of material that comes from rocks or living things. What processes make sedimentary rock? So we're going to go ahead and answer that question on page 74 and complete the 2 questions on that. So, sequencing sedimentary rock formation. Sedimentary rock forms in layers that are then buried below the surface. Formation occurs through a series of processes over millions of years. We're going to summarize how sedimentary rock forms by using the flowchart to sequence the following processes correctly: transportation, compaction, cementation, weathering and erosion, and deposition. That is a hard word for me to pronounce, and I don't know why. Anyways, we're going to move on. So we're going to start with weathering and erosion, which is then going to move to transportation, because the weathering or tearing apart of pieces those pieces can then be transported. The deposition of that is when those are then, after being transported, they land somewhere or they are deposited in a location. Compaction happens next, and those pieces that were deposited then get compacted into all the other layers. And cementation is when they are dissolved and compacted together with everything else in the layer that they're in. So which 2 processes turn layers of loose sediment into hard sedimentary rock? And that's of course going to be compaction and cementation. Metamorphic rock. So metamorphic rock forms when a rock is changed by heat or pressure or by chemical reactions. When high heat and pressure are applied to rock, the rock's shape, texture, or composition can change. Most of these form deep inside Earth. When plates collide, they can provide enough pressure to chemically change a rock. Foliated means the parallel arrangement of certain mineral grains that gives the rock a striped appearance. Okay, so on page 75, we have the academic vocabulary. So applied is the past tense of the verb apply. What is applied to the rock that causes the rock to change shape and composition? You're going to underline your answer in the text. So your answer that should be underlined on that page at the top is heat as well as pressure. Then we're going to go ahead and do the reading check. So explain the basic difference between igneous and metamorphic rock. So igneous rock is made from the cooling magma or lava, whereas metamorphic rock is old rock, which is changed by pressure and heat. Metamorphic changes, figure 5. Heat and pressure can change one type of rock into another. Label each rock sedimentary, igneous, or metamorphic, and then indicate whether the metamorphic rocks are foliated. Then shade the correct arrowhead to show which rock can form from the other rock. All right, so we have granite, which is igneous, and we have gneiss, which is a metamorphic, and it is also foliated because there are those vertical lines there, right? If you put heat and pressure on granite, it is going to turn to gneiss. So we're going to shade in the right section. Now, if we have marble, which is metamorphic and it's not foliated, and limestone, which is sedimentary, also not foliated, and we put heat and pressure on that, the limestone is going to turn into the marble. So we're going to shade the left side of that arrowhead. The flow of energy. No matter what type of rock is formed, it formed as a result of the energy that flows through the Earth system. Forces that drive sedimentary rock include weathering and erosion. Pressure from the interior is a force that drives metamorphic rocks, and heat from the interior is a force that drives igneous rocks. So now we're going to go ahead and answer the questions on page 76. So with figure 6, a volcanic eruption brings up magma that will be subject to weathering and erosion when it cools. Would you describe the processes that change the rocks making up this volcano as fast or slow? Explain. So some processes, like the eruption, are fast, while other processes, like weathering, are much slower. Our next question, summarize text. What are the sources of energy that drive volcanic processes? Energy from the sun drives the rain and winds that weather and erode the rock. Heat from the Earth's interior drives the eruptions that add rock to the surface of the volcano. All right, and now we're at our lesson 3 check. So 1, what are the 3 major kinds of rocks? Remember, we have igneous, sedimentary, and metamorphic. 2, what is the source of energy that drives the weathering and erosion of sedimentary rock? And explain. The sun is the source of the energy. Heat from the sun drives the wind and water cycle on Earth. The action of water and wind withers and erodes the rock. 3, high heat melts a deposit of sedimentary rock, which then hardens into new rock. What kind of rock forms? Explain your answer. So igneous rock. Igneous rock forms from the cooling of melted rock, which is magma or lava. 4, you are examining a sample of igneous rock. What factors affect the kind of igneous rock found in the sample? So the temperature of the magma and its composition affect the kind of igneous rock that is formed. 5. If rocks such as the sandstone formations in Figure 1 are constantly changing as a result of weathering and erosion, then why do they appear to be stable and unchanging to us? So these formations are constantly changing, but the changes occur on a time scale much longer than human lifetimes, so we are not able to witness the slow change. Another concept that goes along with this is, so if you go and say you have a family member that lives far away from you, and you only get to visit them during holidays. So let's say they only see you at Christmas time. And every Christmas they're like, wow, look how much you've grown. Compared to your parents who see you every single day and they don't necessarily notice the change because they're with you. So those changes happen all the time and they're so small during that consistent time of seeing you that they don't notice the changes. Whereas someone who doesn't see you for 6 months sees the change very evidently upon being around you again. So that's the same kind of concept here, is that the time frame that we see. So even though, we go see something, a formation, a rock formation, and it's changing, it's not going to look much different for us in 6 months, 8 months. However, 10 years down the road, it might look a little different. 20 years down the road, it might look a little different. And it's that variation in time which makes the difference.